Hello and welcome to the Front End Horse live stream. It is Component Carousel. It's Wednesday. It is Component Carousel. We are here. We are building out a fantastic, cool new component, and it is October. It's the first Wednesday in October, and so we got a new theme. And before I introduce my fantastic guest, that theme is Supervillain PR Agency. And I know you're saying, what were those words? I'll say them again. Supervillain PR Agency. So the PR agency for like Lex Luthor to keep his his image squeaky clean, so that when he goes out and does all his dastardly things, this agency gets called in and they're really good, and they kind of they make it a little bit nicer, they make it a little bit better, or rather they make it look better. They're a PR agency for monsters basically, and that's what we're doing this week. That's the website we're building out this month. And my guest, we have some fantastic people in the chat. Leaf Pixel, thank you for that sub. You are just a fantastic person. And I keep saying Leaf, I apologize. Life, I apologize. Luke, awesome to have you on here. Luke Bailey, how are you doing? Good to see you.
I'm good, Alex Tross. How are you doing? Nice to see you.
I'm good. I'm great. We've been chatting for a little while now, and I've been excited about your component. I think you sent it to me almost a month in advance, something like that. You were so prepared. And yeah, I've been excited for it ever since. And that's not like look at the nerd. No, I'm just saying like I'm letting everyone know how long I've been like holding on to this and being like, oh, this is going to be an awesome episode. Sometimes it's like a day in advance. Sometimes it's like a week in it. But yeah, I just want to say, it's a really cool thing you put together for us. But some people in the chat might not know who you are. So would you mind giving us a brief intro into who you are, maybe where you work, what you like to do, that kind of thing?
Yeah, totally. I haven't prepared this bit, but
I didn't ask you to, so that's on me. If he gets something wrong, chat, if he gets something wrong about himself, if he botches where he works, that's completely my fault, okay?
Yeah. If I can't remember my own name, then
exactly.
It's Alex's fault, all right?
Blame me.
Yeah. My name's Luke. I'm a creative front-end developer. I work at a place called Green Chameleon, which is based in Bristol, but I actually live in London now. I'm from London, and I'm back here working remote now for GC. We make all kinds of web things, I guess, mainly websites, but we do a lot of WebGL and 3D focused work. Yeah, that's where I work. It's a lovely place. Apart from that, I'm just a pretty regular dude. There's not much to report, really. So that's me. Hello, chat and everyone.
Awesome. Yeah. So yes, you got the chat under you. If anything important kind of comes up, I will try to snag it and make sure that, if someone asks a question, don't feel like you need to be monitoring chat all the time. That's on me. You've got everything else. But yeah, I just dropped. And Life, thank you so much for dropping Luke Bailey's. It's making sure this is your actual website.
That is the actual website. There's not much on there.
Oh, good.
And I think it's broken on mobile. There's some stuff that's broken on mobile. I mean, it's perfect.
Downplay.
It's a great
don't have
website.
to go in and say, "Oh, here's everything that's terrible about this website." It's awesome. Let me show it real quick. It's super cool. It's clean. It's simple. It's beautiful, man. It's way better than mine. Yeah. So all good. It's just
I did that classic thing of not being ready, like getting a portfolio together as a freelance dev is just, I just never find the time. And I had a really outdated site, so I kind of just boshed that one together really quickly. So I had something new.
Is that like a mat cap on there or no?
No, that's actually
HDRI
like a
that's
a HDRI and a reflective material. So
yeah,
probably
cool.
a bit more of an expensive way to do it. I think a mat cap would have been much better.
Yeah, no, I mean, no. The way you did it is perfect. So once again, going back, the way you did it, exactly how I would do it. But perfect.
Thanks, Alex.
And Life in the chat supports it. Flashy 3D with a placeholder. That's exactly what his website is too. So you are in good company. But yeah,
nice.
So we are thrilled to have you on. I also dropped in the link to Green Chameleon into chat. So really excited to get into some stuff. So I came to you and I said, all right, supervillain PR agency. And you basically said, I've got a cool idea where basically we can, why don't you explain your idea? Because I'm going to do a terrible job of it. I came to you
Yeah.
with that, and
So
what are you thinking?
PR agencies, they need to keep their finger on the pulse. They need to know what's going on. And so what we're going to be making today is a 3D globe that we can put markers on, and we can orbit to those markers. Just so the PR agency has a nice visual of, I don't know, all of the crimes that the kind of bad guys are up to. I think that's the idea.
The events that these people were unjustly accused of, right? Come on, thinking
Yeah,
that
sorry.
PR kind of thing, right? Crimes, no. These are innocent people. So
Yeah, brand activations.
that's it. Yeah, did a nice little brand activation in Sokovia, if we're thinking
Exactly.
Ultron. So yeah. Awesome. So,
Nice.
so we've got this starter, and I'll drop this starter into chat. Oh wait, it is private, so maybe you'll open that up
Ah,
by the end of the thing. If
yeah.
that takes a few minutes, that's fine. Chat, we will get this to you in the show notes. So check those show notes if you're watching after the fact. Uh, Click like and subscribe on YouTube. Do all that stuff. Future viewers. But for the viewers
Yeah.
here, sorry, you will check it out later. But yeah,
Sorry.
no. It's all good. All right, cool. So we've got our starter. Should I spin this up or run npmi? I think.
Yeah.
And
I should have a README in there. I can't remember what the things are. I added the README at the last commit, so you're
oh,
at the
good. Oh,
first
yeah.
commit.
So
NPMI, I
here
think.
we go. Yeah,
Yeah.
npm install, and this is an 11t site, correct?
Yes. So it's Webpack with 11T, which
Awesome.
is my favorite way to make static sites. I
We've
think
got
11T is
we've
great.
got a lot of 11t fans in the front end horse
So
community, so
good.
you are in very good hands, or in good.
Good
You're so,
company. Yeah.
that
I mean,
company.
I can
That's
see
yeah.
Ben D. Myers in the chat with WooGo 11T. Ben
Ben
knows.
Myers, a big 11t fan. Lots of 11t people around here. Cool. So I did an npmi. What should I do from there? I think the .env stayed.
Yeah. So we have an env.sample. But yeah, if you've checked back out, it probably stayed. But the
Yeah.
thing
Oh,
you'll want
I
to
am not
do
showing it to you. I'm
is
so sorry. I thought I was showing my
oh
screen. There
yeah.
we go. Cool.
So so we've got this env sample. What you'll want to do is make sure that this is all up to date. What do you use for your vhost? Do you use like MAMP or anything like that? How do you get that set up?
No, so I don't know much about that. When I ran this before, it just kind of worked. Um,
Okay, well this is only for really for browser sync. So in that case, you can
okay.
probably just run npm start and we can ignore the env stuff. Um, and hopefully on localhost you will have some things.
Got some stuff showing up, and then here we go. Are we getting UI or local?
You want to go to local.
Cool.
So that top link.
All right.
Great.
So
We have nothing. That's exactly what we should be seeing.
and just so the chat can see, we actually have a little. We're hitting 60 FPS on this. This is pretty performant. This
Thank
is
you.
pretty performant black screen so far. So we're off to a good start.
Yeah, so that little thing in the corner you might see around on WebGL sites. The library is called stats.js.
Cool.
It's a good little one.
I'm
It's
gonna
good.
pop this out and put it there-ish so that people can actually see it, because otherwise the chat covers it up.
Oh
Although
yeah.
I don't know if that's the most exciting part of it.
Yeah.
We'll see how it goes. We'll
Yeah.
see.
Yeah. Cool. So, we should probably put some things in this black space. What do you think?
I think so.
Okay.
This is
All
the Book of
right.
Genesis. I think is how that started, right? I think that's the
Yeah,
first line in the Book of Genesis. We should put some things in this black space. That's verbatim from the Bible.
exactly. Yeah. So there are going to be some textures that you probably don't have actually. So I might have to send you another commit hash and you can jump forward.
Sounds good.
Um, I think that's probably because what we've done is we've jumped to the start. I've got this repo which has each of our steps in, and we've jumped right to the start, haven't we? So let me copy this commit hash and send that to you.
And we're just doing this in order to get some
Some
files.
textures in. Yeah, exactly. I could actually, do you know what? It might be, yeah, let's do this. Now, if we go back to our screen, we should see an earth, and we might have to reverse engineer how we got to that point.
Okay. So I'm going to run npm start from that commit, and then we're going to see an earth, you think?
Maybe. I mean, I'd hope so.
So it's
But
exiting with 1. Is this handle error from binding ctx? Do you know what this
what's
might
it saying?
be? No such file or directory. No assets models. Okay, so it's complaining about the lack of models.
So this is because we don't have something. This is all boilerplate stuff. So all you want to do in here is just create an empty folder called models.
Okay. So in resources, assets.
Just create an empty folder called models.
Okay.
This is just because we've got some dodgy stuff in the Webpack that's looking to move a folder called models. Hopefully we've got everything. We've got models, we've got images, we've got JS.
Cool.
Great. Okay, cool.
Laravel mix. Interesting.
Yeah, so Laravel mix is really cool. It's basically an abstraction. I know most people love writing Webpack files.
Yes.
Notoriously a fun job. Webpack mix basically abstracts a lot of the like common stuff. And so that's something we like to use at GC. And it just makes writing Webpack less painful is the idea. It ships with Laravel.
Okay.
So it's like it's a legit thing. Hey, here we go. Look at that.
Nice. Okay.
So this is a few so this is a few steps ahead of where we actually want to be. So the first thing that I think we should probably do is go to our code editor and open up a file called earth.js.
Okay.
So it's going to be in JS components, and then or that way.
Yeah, it's a shortcut.
And so
and Chad is feeling your pain with the Webpack. Our friend Jacob is dealing with that right now. So Jacob, have a happy Wednesday, buddy.
Enjoy your Webpack, man. So we've got this earth component, right? Now there's a lot happening already. So I'm gonna ask you to delete okay, can you update that shader material to actually I tell you what might work. See, I don't know what's the right way to do this. Okay, let's just create a sphere first. Let's ignore these uniforms.
Okay.
Let's jump back and just create a sphere. So where we have new shader material, can you write new, just delete that entire shader material down in the super. So if you go to that super, and just remove and just delete that and write new mesh basic material. Not dot, so it should just be mesh base. Cool. And now we're not importing this at the moment. So if you want to just pull that up into R3 up there, import, and now hit save. We should just have a sphere that we've created.
Nice.
Great. Okay. So let's go back to Earth and let's talk a bit about what's going on here. So now this Earth class.
Sorry to this. Yeah, got it.
Yeah, so back into the code. The Earth class, if you look at the top, we're actually extending the mesh, the like native 3 mesh. Nice orbs that someone just threw into the party.
To let you know, they can throw up any emoji they want, and so they're very good about finding very specific emojis, and they found the white circle emoji just kind of spot on.
Perfect.
So nice just letting you know if that throws you off, that's just like a celebration of something. So
I like it a lot. Okay, cool. So what we're doing here is we've got a class that extends just the basic mesh class of 3, and we're calling it Earth.
Okay.
And so ignoring the uniforms, we're calling super. So we're creating a new mesh with a sphere buffer geometry, which we've arbitrarily set to a radius of 100 and we've got width and height segments of 64 and 64.
That's
If
like
you were to
the
change,
count of how many
yeah,
yeah,
exactly.
how many segments
If
are
you
going
wanted to change
around.
those to like 4, both of them to 4,
Be like
and
a square.
refresh, you can, yeah, you can kind of see, you can kind of get an idea of what that's doing. It's subdividing, or it's kind of, so you can see there,
Right.
we've now got this kind of like
And it's still a sphere,
octahedron.
so it's like kind of
Yeah,
chunky. Got it.
yeah. And although it looks flat, because we're using the mesh basic material at the moment,
Cool.
which doesn't respond to light at all. That obviously just a sphere from the front is just a circle if you
Right.
haven't got any shading on it. So right now we've got a sphere, and that's pretty cool. Uh, I'm wondering if we should talk about like where this sphere is created and maybe some of the boilerplate actually before we go any
Yeah.
further.
And
Now we're at this
and
position.
and one thing I do want to mention is I'm not the best object-oriented programmer. I just generally do functional stuff. So this isn't like, like I know what I'm looking at, but I'm also not as familiar with building this way. So just giving you that kind of a heads up, and I'm assuming some of the chat is going to be the same way. So anytime you
Okay,
kind of touch
cool.
on like why we're doing it this way in a class-based kind of way,
Hmm.
that's awesome. But yeah, but
Yeah.
but
And if you've
the
got
way
any
you just said it
questions,
was perfect. So thank you.
cool, no worries. And if you've got any questions on why we're doing anything, ask me, and maybe I'll have a useful answer.
Sounds good.
Um, so the going into the boilerplate a bit now, we're already here. Let's take a step back. This our entry file, our entry JavaScript file is theme.js. So if you jump into theme.js at the bottom, you can see here we've got this very small file that's doing a bunch of stuff. Now, there's some goodies in here. We've got global events, which is a little thing we use at GC, which basically does our event handling.
Okay.
So you can see here, we can just like do a bunch of things. We're enabling
Huh.
We're enabling some events, and you can also see that we have e.on at the top, DOM content loaded, not right at the top, just a bit lower.
Got it.
That's like a micro event handler, very similar to, I think it's called emitter or something, that Jake at GC, his name's Jake Whiteley, he made
Okay.
this.
Cool.
And it's just a micro event system. It's really cool. It's on NPM.
Nice.
So that's what we're using here. We won't go too much into detail with that. We're gonna just walk through this line by line.
But
So
like being able to
when
do
once
this stuff is so handy for
yeah,
if
and so
because a lot
what
of
we
it's
can
boilerplate.
yeah, it's really nice. So what it means we can do is we can very easily use E in combination with this thing called global events to do really cool things like just normalize and abstract away that common stuff of like adding event listeners. So if we did want to, detect mouse movement here, we can just now do E on mouse move, and then we can add our callbacks, and we can just listen into these global events. And E's smart enough to, you can delegate with it, you can do all sorts. That's a whole other stream, getting into all of that stuff. So we're enabling some stuff at the top. I don't think we actually need them in this project. The same with the RAF collection. That's just a thing that we use
what is
to.
RAF?
So RAF stands for Request Animation Frame.
Got
And
it. Yep.
so when we're animating stuff in the web, we'll create a loop where on an animation frame, which is when we can render a frame or paint a frame, we can run some code, and then at the end we can call it calls itself again, and that just creates a loop. So for every frame that we can show on screen, we can do stuff.
Cool.
So the RAF collection is, again, another little abstraction that we use at GC that we don't need to worry about. The asset loader, again, is another cool little thing that we use to load up assets. Then we've got WebGL, which is where we create our WebGL things.
Okay.
So if you go into WebGL.js, so that's kind of it for this theme, which is
Just
that theme file.
super quick, the focus manager. What does that handle? Like focus as I think about it?
Yeah,
in
it
terms of
does. It
like
does.
tabbing through and
It's
focusing on things?
exactly, yeah. So that is something, again, I'll probably end up removing some of this stuff on the boilerplate before I make it
Cool.
public. But that's not really used on this project. It's just part of the
The
boilerplate we
boilerplate.
use at
Cool.
Unseen.
That's great
And it's
though.
yeah, it's really nice. It basically just gives us a few extra nice things that we can do with focused elements, because sometimes it gets a bit complicated at GC with the kind of crazy stuff we build, that this focus manager can help bring back functionality that we break because of just doing naughty things, basically.
That's great. Yeah.
Um,
One thing we kind of touch on often on the channel is how like we can make some really cool things, but then they don't get as accessible as we would like them to be. And so it sounds like this is something that can kind of help get us to that thing of like it's a great experience and it's accessible, because that's kind of like the
yeah,
dream, right?
yeah, and that's a hard balance.
Right.
So yeah, let's jump into WebGL. Um, this is basically where we set up the Three.js kind of stuff that we'll need. And again, there's probably a bunch of fluff in here that we don't need. But you can see we're importing some things from Three. We have that stats module, which is giving us our FPS
Got it.
counter. We use a global store, which is just an object that we import. And that's how we can, it's a very simple state management. That's what store is. We're bringing in E and global events again. We've got the GLTF loader, something that we don't use in this project, and it's just there. But that's where you'd import it
It was like a
if you did
3D
need it.
model, like if
Yes,
cool.
yeah. If we're so this is a similar boilerplate. So the website that I built for myself, that it uses this boilerplate, and on
Awesome.
that I've got a GLTF model of the arch, and so I load that model with the GLTF loader, and then we can start to do things with
Awesome.
that mesh. Um, so we'll go down. We're just setting up stats. We've got a nice thing here where if we put in hide stats as a query parameter into the URL, it will just hide the stats, which is
Nice.
quite useful.
Yeah.
Yeah, it's sometimes useful just to like be able to look at the site without all of your rubbish on there, you know?
Yeah, especially if you're sending
Um,
like a demo comp to a client and they're like, I don't like the little thing at the bottom. And you're like, the one thing I didn't want you to look at.
exactly. Okay, and so then we go into a setup. And this is pretty standard Three.js setup, where we have our renderer, which we create, the WebGL renderer. You can see here we're setting some shadow map stuff. We're setting the size of our renderer. We're passing in the canvas when we create it. I'm going to whiz through this so we can get to
Yeah,
the good
yeah,
stuff.
we've covered this a bunch. So to anyone who's just watching this for like the first time, you're new to the channel. We've covered like setting up a 3JS project, and for the most part, once you've done one, you've done one. So you can go back and check out some previous videos. I definitely don't want this to be the channel where like the show is all about creating a scene and adding your first camera, and that's every video. So yeah, happy to kind of skim through this at this point. So yeah, it's all
Great,
good.
brilliant. Okay. Now in here we'll have build, which we scroll down, and that's where you can see we create our earth. We say this dot
Cool.
earth equals new earth, and then this dot scene dot add this earth,
Got it.
and
And
that's
that's
just creating our
this.
scene, and that's that.
Got
But
it.
you'll notice it's in build, and the reason it's in build and not higher up is because what you want to do when you're creating a 3D thing that's got textures is you'll generally want to wait until those textures load before you render that thing on screen. Otherwise, you'll have your white sphere, like we've already got now,
Right.
pop in, or something different. It depends what material you're using. But you'll have your material pop in, and then any of the like texture maps, anything like that, pop in later as the file gets loaded. And
Got
so
it.
to avoid that kind of like seeing the model and then having the texture on the model, having that kind of flash, it's kind of like the equivalent of a flash of unstyled content, but in the
Okay.
WebGL world,
That makes
basically.
sense.
So we do that in build. You can see loads of code that we don't really need here that we're
Yeah,
not going to be
but it seems
using.
like we're
But
loading textures, so
yes,
that
oh, we do need that.
those
Yes.
JPEGs are going to be a lot bigger than a sphere, right? The sphere is really easy for the renderer to create, but the JPEGs are going to take a little bit of time to download and then put out.
Yeah.
So what you just said, that's why.
Yeah, exactly. So, well, normally what will happen is your JavaScript file loads and starts executing, and then that will create your Three.js scene. It will create your objects, and it will start rendering them, and it will also then start loading assets. And so it's not necessarily the renderer takes less time to get the object with a texture on it into the scene. It's that it literally doesn't have the texture at
Right.
the point in which it's putting that into the scene.
Right.
So yeah, we load our textures, which you can see we have this, we're calling a few things, but we load some assets, we load our textures. So this is basically passing in the URL of our textures. We have this store assets URL. At the moment, that is just a /. Sometimes on projects, you might want to put assets somewhere else.
Cloud
And
Mary or
so
something.
exactly. So this gives us a nice way to just like set the root of our assets in a centralized place, and then we can just write the rest of the URL. So here we're just pulling in an Earth day map, an Earth night map, and then an Earth water map. Although I feel like we don't use the water map in this, but we'll see. Maybe I don't think I did. I ended up using that specular map, but we're loading it anyway. And so then we loop through that object, and we add it to our asset loader. This is again something that we use at GC. There are probably other ways of doing this. The asset loader on a top level basically allows us at the start of the project to like add all our assets, and then it loads them all and it tells us when all of our assets are loaded. Cool. It's also useful if you want to do an actual loader that like each time you load an asset, we can progress a loader.
So
it's
like
useful to do that.
a bar kind of loader is what you mean?
Yeah,
Got it.
exactly. Yeah. If you want to show real progress of a loader, you can do that here. So the add function here basically adds that promise that we create. You can see we're adding a promise, which is the loading of that texture. We do texture loader load. Yeah, zoom in. That's useful. We pass in our texture. We load it. We set the min filter and the mag filter to linear filter. Now that's just something that helps with aliasing, basically.
And aliasing, for someone who might not know, how would you
So
describe that?
alias, yeah, I guess the easiest way to explain it is like
I know
when you have,
anti-aliasing, right? Like
yeah, exactly.
it's for
So
edges and
that's what,
things, right?
yeah. So this is for anti-aliasing. It's for when you get to the like edge pixels, or you have something that's trying to render itself and it's actually a subpixel. This is just how the WebGL program samples the pixels. Cool. So that you can have like less jaggedy edges and pixelation for like fine lines and stuff like that. We also flip the Y of the texture because it gets pulled in and is upside down. So we flip it on the Y axis. I don't know why that happens sometimes and why that doesn't. That's a gap in my knowledge, but I know that if we were to turn that to false, we'd have upside down textures.
Upside down.
So
okay.
So you just flip it on the Y. Then this is a cool trick that I think people will like. The next line is we init the texture. And that is essentially like preloading a texture onto the GPU. All of this stuff gets passed to the GPU. And when you load a texture to the GPU, it takes some time. And by adding this init texture, which is just a Three.js method that's on the renderers, it basically forces it straight onto the GPU. And so when you've got loads of textures going on, or you're in a project where you'll say you have a page that has a model on it with textures, you won't, if you didn't do this, only at the point at which you're then going to render the texture will it upload that texture to the GPU, and there will be a pause and a gap like where it does that work. and you won't have the texture. So by doing this, you're kind of like preloading all the textures, which we
Got
don't
it.
really need to do here because it's
Right.
all on screen straight away. But if you have stuff that's off screen,
Right.
this can prevent the
I
kind of like flash.
can see like a
Again, a flash of
carousel kind of thing. If I'm about to like hit the next thing, you would want to init that texture so that when I hit next, then it goes to the next product that's like 3D. It doesn't have a while and then pop in all of a sudden. It's already preloaded, right?
exactly.
It's cool.
Yeah, totally. And then we just store that in an object called assets, which is part of this WebGL class. The other thing we're doing is, you can see here's a good example of E being used in add events, where we have a resize event, we have a store where we add our RAF events, and that basically is just telling it that when we start rendering to call the RAF, the request animation frame callback in here. And so the resize stuff that we do here is standard resizing that you'll want to do on most of your Three.js projects, just resetting the renderer's width, the camera aspect ratio, and that's
Otherwise
kind of
it
it.
gets smushed, like the shapes start to get all wonky, right?
Yeah, because you load up at a certain size and you tell the renderer that it's a certain size. And then when you update the screen, it will literally just stretch that like you were stretching an image in Photoshop as the window changes size.
Cool.
And so this just fixes that.
Awesome.
I don't know what else is in this file we might want to talk about. It's basically it, really. We've got our RAF, which people will recognize what we're doing in here. It might look a bit different to the way that you've seen it done, but we're basically just calling render on our renderer, passing in the scene and the camera. That's the important stuff here. The stats begin and end is what enables us to get our frames per second. The clock delta, don't need to worry about that for now. That's just working out the delta time of the scene.
Okay.
And then we have a global time uniform here. Although I don't think we'll use the global time uniform in Earth. I think we set it up ourselves. I can't remember. So yeah, that's the WebGL file. That's kind of a rough in on the boilerplate.
Awesome.
I hope that wasn't too crazy for everyone, but that's
so we've got a good amount of boilerplate that we're working off of. So it seems like it's good advice that if you're going to be doing this sort of project a lot, find a boilerplate that kind of has batteries included and gives you a lot of helper functions and things like that to let you not have to do the same thing over and over again, because I feel like that can be a lot of Three.js projects where, as I said, you're kind of creating that scene, you are adding a camera, you're doing that kind of stuff. You have to handle the window resizing. All that stuff is like in every single project, and so not having to do that from scratch every time. This kind of a thing makes a lot of sense. It's awesome that Green Chameleon has made a few helper functions. And before we go, make sure we get. You said this utils
the
one
E.
is on npm. So let's make sure
Yeah,
we get that before we go. So funny.
totally. Yeah.
So many people are asking for the demo link to the globe that we're working on. Would it take you a while? I think that's like the third person to ask.
Yeah, no, while we're chatting,
Okay.
I'll do a lazy dev thing, and I'll just like drag and drop this onto Netlify if that's cool.
Oh yeah, cool.
That would be the quickest way I can get this.
I wasn't sure if Bavi was talking about the code or the demo, because yeah, the demo itself can wait actually, because that's a bit more fun to show everyone at the end. I think they meant the private repo. We can just hold off. It's all good.
Okay. Oh, right. Okay. Cool.
We'll have it to you by the end, Bavi. All right, or it'll be in the show notes also after.
I'll do it straight after the stream. I'm about, so I can totally just do that after the stream. I'll be on the Discord, and I'll chat to everyone and I'll put that up. That's not a problem.
Cool. So into the boilerplate, and we got our Earth.js, and we're making a circle.
So we're making a circle,
or a sphere rather.
A sphere that is looking pretty crunchy right now, because that's at 4.
There we go. Now
it's a little
better.
Nice. Smooth. Great. Okay. So we are going to need to change that mesh material to a shader material, because to do what we want to do,
Okay.
we need to write our own custom shader. So
Nice.
where you see new, you want to change that mesh basic material to a shader material.
Do I still do new?
Yeah, so it's new and then just shader
Cool.
material. And then we will have a shader material. Now, if you refresh now, you still wouldn't see anything. In fact, yeah, you just see a red one.
Yeah.
Yeah. So we're going to need to add in our uniforms. So
Okay.
the first thing that a shader material takes, well, the shader material takes an object. It doesn't take like params in the same way that the sphere buffer geometry does.
Interesting.
So passing an object, and the first thing we're going to want to pass to that is our uniforms, which we've got above. And you can see all our uniforms all our uniforms are right now is some textures. And then we're going to want to add in some shaders. So we've already got these created, but if you write the word we've imported them using the names that are the keys. So the next thing we'll want to do is write fragment shader and then vertex shader as the next two values here. Perfect. Cool. Now, we're already going to have our earth set up here. So I think if you save this file, let's go to our fragment shader. Okay. So that's where we're going to end up.
Cool.
But we're gonna strip it back and then we'll add that back in. So
trying to head over here.
If you go to our earth, yeah. So GL.
All right.
So yeah, it's because our imports in this project are annoying. We're using _GLSL, which is I think a Webpack proxy or something, so that we don't have to write out the full path depending on where we are in the project. We can always just write _GLSL and it will always point to this folder.
Got it.
So I reckon, I don't know. I don't know what will happen here actually. Yeah, so let's just delete those top two lines where we have the day sample. Sorry, yeah, within the main, which is within there. Actually, let's talk about those top two lines. So we have a varying uniform, and then we have a varying, and then we have a uniform. The uniform is a sampler 2D of the day texture that we're passing in. And the varying UV is actually something that is defined and passed into this fragment shader by the vertex shader. And that is if you go into the earth.vert, you will see we're doing.
Should I install something for this so we get?
Yeah. I would recommend that. Then we'll get some syntax highlighting.
There we go. Cool.
Yep, that's the one that I like to use.
I think I'm an official shader guru now. Now that I have a plugin, it means I'm good at this now, right? Because people
exactly
don't do shaders don't have the plugin, so pretty
exactly.
Official. All right,
cool. That's nice. We've got some syntax highlighting.
There you go.
Lovely. So we're using a shader material which gives us basically some boilerplate, which is really nice from Three.js. They do have a thing called the raw shader material, which is, as it sounds, a raw shader material without any of these values passed into it. So you can see we've got a few things in this shader that we actually don't have defined anywhere. We have this thing called UV, we have this thing called projection matrix, we have this model view, and we have position. Right. And these are all part of shader material and part of that boilerplate. The UV is the UV of the model that we're using. The UV is the coordinates of the screen, the UV coordinates of what we're looking at. I think clip space is the right term for that. Or maybe I'm not sure. And then we have the GL position, which is the projection matrix times the model matrix times a vertex 4 of the position with 1 at the end of it.
So position is going to be 3.
that means it's a
It's three
vertex 3. Yes,
values, and then that's the fourth.
exactly.
Got it. So just super quick to
Exactly.
say back what you said. You're pointing out how this and this, the UV, the model view matrix, they all come from this. When we create this, those kind of come as default, or they get passed in from that. Like those aren't coming out of
Yes.
nowhere. They're coming in when we create shader material. Those come along for the ride. So those are built in. We don't have to figure those out for ourselves.
Yes, because
Cool.
all of this stuff eventually compiles down to one WebGL program. And so Three uses these uniforms in all of its materials.
Okay.
And so they get predefined at the top.
Cool.
And so, yeah, if you want to look into that more, in the Three.js docs, for anyone in the chat there, if you look at the WebGL program, I think if you search WebGL program and Three.js docs, you'll find the page that goes through and has all the built-in uniforms that you see here and a bit of information on them. So yeah, these are all passed in. The model view matrix this is where it gets really mathy, and we won't go into it too much, but this is a concatenation of the model matrix and the view matrix. Don't ask me what those are. Then you have the projection matrix, which is the camera projection. And all of those things together give us the GL position, which is the kind of the part that we're looking at. Because I don't know how much people know about shaders in the chat or that are watching this, but a shader will run through each pixel of what it's drawing. And so whenever we're looking at this main, we're kind of looking at a pixel at a time. This kind of runs for every single pixel.
And it all happens at the same time. So pixel 1 doesn't know about pixel 2 and can't like get data from that. They're all being run at the same time. So it's kind of like an isolated function that's being run, right?
Yeah, exactly. We're looping through it, and yeah, these things we can't pass information between. There are ways of doing that, but again, that's quite complicated and maybe something for another time.
Nice.
Okay, so just for fun, where we have our final color, where we're creating our day sample, let's create where it says day sample. Can we start typing there and start typing vec3? And then within there, we're going to do VUV X, VUV VUV.X. So we're going to get, yeah. And then, or actually, I think we might just be able to write VUV, comma, 1, like we're doing with the vec4 below.
Because this should have X and Y on it, is why.
Yes.
So for people in the chat,
exactly.
if you're new to the vec3, this is just essentially, I think of it, I know this isn't like a perfect thing, but essentially saying like, I want an array with 3 properties. So like when you see vec3, you need 3 things in there. Right now we're passing VUV X and VUV Y for the first 2, and then 1 is the third property, right?
Yep. Now this actually will break at the moment because the one that you've written is an integer. And something that I always get caught out when writing shaders is that we're writing floats every time. So unlike JavaScript, where we don't care about the type as much, here we do. So if you were to just write 1 without .0,
and I do all the time, I always do.
So in shader world, so here we go. We've got a sphere, and it's got some cool colors on it. Yeah, right. So what is happening here is the UV that we're passing through is that number is changing as we're going around this sphere. And it just so happens that we've got this nice blue with a purple at the edge. Yeah, thank you, chat, for the blue spheres. And so this is just because at the top, the UV is going to be 0 in the top right-hand corner. The UV is 0, and we're using the X of that and the Y of that. So 0, 0 in an RGB world, because what we're using, we're mapping 3D coordinates to colors right now. So where the X represents the R, the Y represents the G, and the Z represents the B.
We're
And
gonna
so
have a
what we're
lot
doing,
of blue. Is this going across the entire screen, or is it just for the sphere?
it's just going to be for the
Ah,
sphere, and that
but
and
because it's
that
3D, we should see different colors around the other side. Is that right?
yeah, if we were able to orbit around
Right.
here, we would see that. Although I think we might have to do some other things to get
Okay.
that. I think with just this setup here, I think this is more of like this is kind of like getting the 2D. It's projecting like onto the 2D
Got it. Okay.
um,
I don't mean to skip
that we're
ahead
seeing.
or ask wrong
No, no,
questions or
no,
anything,
that's
but
fine.
cool.
No, that's cool. No, ask away. So that's just what happens when you pass the UV in. Um, uh, yeah. So now we're going to go to that top line. And what we're doing is we're getting a sample. Sorry, the top line in. I keep saying top line,
It's
but I
all
don't
good.
mean the top line. I should just say like line 6, shouldn't I?
That
So
works. It's all good.
that's way better. So on line 6, we are using this texture 2D method, which basically is a WebGL method that reads our sampler 2D as a texture. So we pass in our texture as the first parameter,
Okay.
and then the current UV that we're on. So what kind of part of this
That's
image?
kind
We
of
got
the
this.
coordinate that we're at, because as we said before, it's all like this whole thing is being processed at once. So we kind of tell, hey, pixel, this is where you live, and then it
Yeah,
chooses a pixel from this image to paint itself. Is kind of how I
exactly.
understand it. Cool.
Yeah, that's totally correct. So it's and this UV is obviously the UV of the sphere, and so the images that we use need to be the right kind of images. And when you're mapping an image to a sphere, you use a thing called an equirectangle texture,
Hmm.
which is just a kind of like a rectangular kind of like if you open up the image file that we've got in images and have a look at it, you'll see that we've got this projection of the Earth.
It's like the
And
Mercator
that,
projection map, and it makes Greenland and Iceland look just massive, and it makes Africa look
yeah,
teeny tiny, right?
yeah, exactly. And that's because you can't ever accurately project a 3D sphere onto a 2D object without cutting into it and creating lines. So this
Right.
projection is the projection that we use. And so this gets wrapped around our sphere.
Cool.
So we then get out of that, we're getting the RGB values out of that, and we're assigning it to this vec3, which is our day sample. And I like to use the word sample when I'm doing these things because it keeps it in my mind that this is just one pixel sampled from the texture.
That's cool. I like that.
And so that's why we do that.
Got it.
Now
Chat, I see
we
you and I appreciate you. Chat is Thomas and Jacob are putting in work in there. So first off, Thomas says, "Is UVU the younger sibling of Uwu?" Which is like the which is fantastic. I don't know
so
if that's how you say it, but it's just great. And
oh,
and then equestrian. I appreciate the effort, Thomas. I appreciate it. And Jacob.
so yeah, I think I'm right. It's equirectangle. Yeah, equirectangular projection. That's the type of projection that we're doing.
Nice. Yeah.
Yeah,
And HDRIs are the same sort of thing,
yeah,
right?
exactly. And if you
Cool.
think about an HDRI, what that's doing is projecting onto like a large sphere that you sit inside
Right.
and then you orbit around, right? So we're just doing the same thing, but the sphere, we're looking at it from the outside. A
Yeah.
HDRI is kind of doing the same thing,
Just
but you're
opposite.
inside the
Right.
sphere. Yeah, it's like a giant sphere that sits around the kind of all your other things in the scene.
Very cool. Awesome.
Yeah.
Thanks for giving us that word.
Uh,
That's
yeah, it's a
nice.
good word, isn't it? It makes you sound smart if you say
Oh yeah, I'm gonna
equirectangular
drop it in
in
dinner
a
conversations all the time. It's gonna be my new thing.
definitely. Yeah, you'll be the cool guy at the dinner table.
Always am.
Um, so so now we have this day sample, and I can see you've assigned the final color to day sample, which is
Should
great.
I remove that? Nope. I
Yeah,
should put
yeah.
that in.
No. I think you should do that. I
Cool.
think we should hit save and we should take a little look at what we've got. And we should have something that we recognize. It's where we live. It's Earth.
Yeah.
So
You sound like an alien trying to like throw people off your trail. Like it's something I recognize, and it's where I live, and it's Earth, and I'm from here.
Yes. Am I right, my fellow humans? What's going on in the chat, my fellow Homo sapiens? Great. Okay, so we've added a texture to our sphere.
Cool.
So we've got this Earth.
Yep.
It's looking okay. It's not looking great. Love the aliens. So now we're going to do some more things. I think first thing we should do is add a nice kind of like atmosphere to Earth.
Yeah, I was just thinking that how like it looks a little naked without the clouds and stuff, right?
Yeah. So we're not going to add clouds. That is something that we can do.
It looks great. It looks fully clothed.
Well, I did think about adding clouds, but this is the thing with the Earth stuff. You can keep going. You can add clouds.
Yeah.
You can add an outer glow. We're going to add like an inner glow, which is Earth's atmosphere. You know, when you look at it on NASA, it kind of has this like blue kind of hue to the edges.
Right.
We're going to add that. We're going to add a nice blue hue to the edges. So we're going to do this in our Earth fragment shader. So first things first, we're going to need to create a thing in our vertex shader called, we're going to have to get our normal. And a normal is, in this scenario, the angle that each face on our circle, on our sphere is facing, right? So so our sphere is made of loads of tiny little squares. They're actually triangles, but let's call them squares for now. Loads of tiny squares. And they all face in different directions. And the angle that they're facing is our normal. And so we need to calculate that because we're going to do, here you go.
Here we go.
So you can see here, Google is great.
Google is great. I think this one's probably pretty good for
normal geometry. That's exactly what we're talking about. Yeah. So you can see everything's pointing the way that the face is pointing. Those arrows are coming out at the angle that the face is.
Right.
So we're going to do that for our sphere because that's a crucial part of how we're going to create a little edge glow. So if you go into earth.vert, our vertex shader, we are going to add a new varying at the top. So if you go to the line 2 and type in varying, this is going to be a vector 3. We need the X, Y, and Z angle. And just call it V, lowercase v, uppercase, and then normal. So you'll notice we're using camel case here, and varyings we're prefixing with V, so that when we're in our code down there, we can see. So that's why we have VUV. The V just stands for varying, and then it's UV.
And what is varying?
So a varying is a uniform that gets passed between the vertex shader to the fragment shader. So cool. The vertex shader is looping over each vertex on our model, and our fragment shader is deciding how we paint that. But there's information that sometimes you want out of the vertex shader, like the UV that we're doing here, that you want to pass over to the fragment shader. You cannot go the other way. You cannot. Oh, nice horses. You cannot go the other way. You can't pass things back from the fragment shader to the vertex shader.
Okay, so that's the way it goes. So it goes like from Three.js down to the vertex down to the fragment, and then it stops. It doesn't you can't do callbacks. You can't.
No,
anything back
there's none of that stuff. Yeah, because we're not in JavaScript world anymore. We're in GLSL world. And it's a crazy world, this one. I mean, you can work. I've been working with shaders for years, and I still often feel like I have no idea what's going on. It's just a completely different paradigm to what you're used to, I think, as a front end dev. But obviously, we can create some cool stuff with it. So it's worth getting our heads into. So we've created this vector 3 at the top. Cool. We now need to give it information. So let's create a new line at line 5. And what we're going to do here is we're going to write v normal equals, and it's going to be the normal matrix. Again, this is some complicated math stuff that 3 gives us. And we're going to times that by the normal. Oh, matrix. I was like, I think you're spelling this wrong.
No, they're a sponsor. I'm obligated to drop that in every time.
Pretty cool sponsor, man.
It would be a really good sponsor. So then just by the normal?
And then normal. Yep, just normal.
Okay, cool.
Just the word normal. And we're going to need, our semicolon at the end. And so that has then calculated the normal that we need.
Okay.
Yeah, we're going to gloss over the intricacies of that. And we're going to jump into our Earth fragment shader.
Cool.
And we're going to do stuff with our normal. Just know that we now have that V normal will represent the angle that each plane is on.
Okay, cool.
So at the top, we're going to need to bring this normal in. So the same way we're doing with the VUV, we want to bring in our V normal.
Okay.
Fabulous. And now under the day, let's create a new line. In fact, let's create 2 new lines. And I'd like to write a comment here that just says atmosphere, just so we know what we're doing, because it's
cool. Looking
at the code, it's almost impossible if you come back to this in a month's time to know what you were doing.
Yeah.
So now we know we're creating the atmosphere. Now I think we should go and pick a color for our atmosphere. We will do that as a vector3. So if you write vec3 and call this atmosphere color. Sweet. And again, vec3 here to create it. Now, if you just write 1 in here, does it give you a color picker? So if you write 1 and then full stop 0.
That cool plugin for that. No.
I think, okay, fair enough. Okay. Well, I know what this color is going to be. It's going to be 0.3 on our red value, 0.6 on our green value, and then a 0.8 for the blue value. And that is a nice tealy blue, that color. That RGB, that's an RGB, right?
Should I refresh or no? We're not doing anything with it yet.
Well, yeah, we're not doing anything with that color yet. Although, if you wanted to, maybe pass that in as the final color, and we can have a little look at the color that we've just written.
Okay.
So just pass that in down there.
Oh, I did the wrong one. Hold on. I passed in V normal. Do that. Nope. Yep. Okay.
Boom.
Nice.
So that's the color that we're going to be using.
Okay.
So head back to the shader and let's get this in. So obviously, as we saw, that color is just a flat color, but we want to kind of change the intensity of that color so that we're only focusing on the edges, and we want to slowly create a gradient across the circle. Now, this is something that Mr. Doob, who created Three.js, this is some of his code that I found. It's actually really smart, and it's kind of mathy, but we can explain it hopefully in a way that isn't too confusing. So we're going to create a float on the next line, on line 11, and we'll call that intensity. Now, what we'll want to do is use this GLSL method called dot. So if you write dot, we're going to pass in our v normal here, and then we're going to create a new vector 3.
Inside
which
here,
is inside as the second parameter, and we're going to give the first parameter and the second parameter of that as 0. We're going to need dots after those. You don't need to do dot 0, but you will just need to do a dot. Yep, perfect. Yeah, you can just do dot. You don't have to do the end. You can just do that.
These rules are just chaos. This is what
I know.
What kind of
right?
rule is that?
I know. Yeah, you don't. It doesn't matter. You can have dot comma in the GLSL world. It can read that. And then for the Z, for the last parameter, we're going to set that as 1.
Okay.
So let's break this down. What's happening here? So the dot product, which is what the dot function does, basically, from a top level, it's giving you the differential between 2 vectors. So the first vector that we're passing into this is our normal. which is as we go around the sphere, the angle in which the planes are facing. We know that. Then we've got the second normal, which is yes.
Sorry to cut you off super quick. If so, for that value, if it's facing directly at the camera, what is that value? Is that 0 or 1?
So, well, that is x0, right? Because on the x-axis, we are where you are. On the y-axis, it's also 0 because that's where we are. But on the z-axis, we're pointing towards you, so that's going to be 1.
Okay.
And one of the things to note about the dot is that you want these vectors to be normalized, which they are. If they weren't, you can pass the normalize function. You can pass your values to the normalize function, and that will normalize your vectors. And normalizing just means that it's then set from -1 to 1.
Cool.
It's kind of like putting it in that range.
Right.
And so we've got a vector as our second param. Sorry, did that explain it?
Yeah. I just wanted to, because I realized, oh, right, so that normal has a value, and it's probably, is it based on the camera position and
yes.
the relationship of the camera to that face, correct?
Yes, exactly.
Awesome.
Well, I think it's actually, it's not to do with the camera. I think it's to do with the world view. So, the world has its axis, its X, Y, and Z axis. And so
got it. Okay.
So here we're creating, and it just so happens that our camera is right now directly in front of our globe.
So it's going to be predictable. Got it. So if we were to move that camera, this wouldn't change. Like the normal wouldn't change, and so this atmosphere would probably look a little funky. But I'm probably skipping ahead a bit.
Yes,
but
I think that's correct. I might be wrong in there. There might be something in the way that we're creating the v normal that changes. I'm not actually sure.
No worries.
I need to add some orbit controls to this and
not
see
trying
what
to get
happens.
you to write your thesis on this or anything. I was just making sure I understood the normal bit as values. So
yes,
cool.
Yeah. So we've got these two vectors, vector 3s, that represent vectors, they're like angles.
Right.
And we're getting the dot product of them, which is the differential. So there's a really good video, actually, if anyone wanted to check it out. I was doing some research on like what's a good way to explain dot product, and there's a really short video on YouTube by Freya Holmer, which I've got linked to. We can put that in the chat notes maybe, or the project notes, and it's like a 2-minute YouTube video, and they just draw out what dot product is from a very high level. But just know it's the differential. It's not quite, so if I've got an upwards angle, I've got the angle here, it's the kind of angle between them, but it's not actually the full angle. It's like the line between this one, the top of this one, and its distance, and to here. But yeah, top level, it's the differential between two vectors.
They were the one who did the Bezier curve, the beauty in Bezier curves. Was that? Is that how I know her name, Thomas? In the chat, he says he watched her Bezier curve video yesterday. Yeah, that was really well done.
Okay, yeah. That is the same person.
Oh,
yes.
Yeah, that was a great video. Shout out to them. Yeah, she does some great stuff.
Yeah.
Super
Freya
cool.
Holmer, super smart. Yeah, explains things much better than I could.
No worries.
So we've got that. That's cool. Now on the next line, we're gonna use this.
Okay.
So we're gonna create a vector called atmosphere.
Vector 3.
Yes. Sorry, a vector 3
No
called
worries.
atmosphere. We're gonna get the atmosphere color, and we're gonna times it by the pow. So now we're going to do times, and then we're going to write pow, which I love writing, which is the power of our intensity. And let's just put the number 1.
Where?
As the next parameter. So power,
cool.
You can take 2 values in GSL.
So cool.
And then what we want to do is just simply, where we have our final color, we just want to add that onto our day sample. So we're kind of just layering this on top. We're adding that to the day sample. So we can just write plus. So we're doing day sample plus atmosphere.
That's like, so just coming from like any other kind of programming, it's just wild to be like, you're going to add this texture plus this freaking number I have, right? Like,
yeah.
this
Think
is a
about it
freaking
like
JPEG. Like
yeah,
to start from
yeah.
that, then be like, yeah, and at the end we just add those together. Like in JavaScript,
Yeah.
we laugh about like, isn't it wild that you can like add numbers and strings and it works? But here it's like you're adding JPEG pixels. Like that's
there's loads of cool stuff like
it's
that
really neat.
in GLSL, and you can also like grab things out of like vectors. Like you can grab YX or XY or ZZZ, and it can just do that. It will then just get
So
those
cool.
values and pass out. Yeah, there's lots of awesome stuff that you can do in the GL world that you can't do in JavaScript.
Yeah, that's cool. So I saved
Yeah,
that. Should we head over?
so yeah. I'm sure it's not going to be quite what we want. I've done that deliberately, but I don't know what we'll get. Oh, I think we've got an error. So if you check your console, I bet this will be.
Over here.
I know what this is already. It's a full stop. It's because we've written a 1 as an integer, not
Aha!
as a
I
float.
did it, chat. I did it. I forgot it again somehow.
I think intensity has also got a typo on it as well.
It does. Good eye. We've
Okay.
done like maybe 4 or 5 shader streams by now. I refuse to learn, apparently.
Yeah, dude, same.
Whoa, that looks really
All right.
cool.
It looks really cool. It's not quite what we wanted,
Right.
but it's closer. It's closer. We've got something going on. Now,
looks like the reverse.
if you look, it is the reverse, right? So if you see, we've got like, we're darker towards the edges and we're lighter in the middle. And that's the opposite of what we want to do, right? So if you go back to the fragment shader, the way that we're going to inverse that is we're going to go to our intensity.
Okay.
Because that's what's deciding how much color we use.
Right.
And so in GLSL, everything kind of operates on like 0 to 1 or minus. There's a couple different systems, but generally it's like -1 to 1 or 0 to 1, right?
Okay.
So that's how we're like scaling things. And so what we want to do is inverse our dot product is just add 1. We can -1 from it, so we can do that at the front or the start. So this is outside the dot vector. Yep.
-1 with a period afterwards. Just for the folks at home who might be new to this or tuned in within the last 5 seconds, you always want to use floats. So always put a period at the end. Take it from me.
Yep. And now we've got. It's looking real crazy now.
This is looking more like how I feel the Earth is headed. Like my doom and gloom around the climate. Like, yeah, that looks accurate. Yeah.
Exactly. And we want the Earth to look pretty. We're a PR agent.
Yes, we are.
So if we head back, I think we actually need to add that 1 at the start. So I think we want to do 1 minus our dot value.
1 minus. Oh.
1 period minus. Yeah. And then we can remove that from the end.
Oh, hold on. There we go. Cool. Nice.
And now we've got that.
Look at that. Yeah. It's got a nice little reflection around the edge.
Yeah.
Or
and so
not a reflection, but just like a bluish glow. That's so cool.
Glow, yeah. And so what we're doing there is, as we've got our normal, we've got this normal facing straight towards us. And then we've got all the normals on this sphere going back round. We're using the fact that there's we know that when we're facing, when the face is straight on to us, we don't want color. And then as we move out, we gradiate out.
Cool.
And so that's what this maths has done there.
Cool.
I think we want it a bit less. So I think if we up our intensity to 1.5, this value at the end,
1.5 here.
The one below, so where we're powering our intensity. If you change that to 1.5, I think it will bring us down a little bit, and just like
feels like it's
there we go.
Yeah, cool.
Yeah, just bring it in a little bit. So I think that I'm happy with that. We've now got a globe with a nice little blurry atmosphere around the edge. Fabulous. So I don't know. We should probably do something else now. I think the next thing that we should move on to is adding some night and some day, because that'd be cool. You know, Earth looks really pretty at night with all the lights on. So let's try and get that in.
Yes, definitely. Let's do that.
Yeah.
So by lights, you mean like we're actually going to show the lights of like the cities and everything. Awesome.
Yeah. You know, when you see Earth from, when you're out in space in your
When
spaceship and you look
you're
down
going
at
to
Earth.
colonize a new planet and you go, that one's pretty. Yeah, that's what we're doing here. Humans.
Exactly. So, my fellow humans, next thing we'll want to do is add so to do the night and the day in the real world, the sun is obviously really important in that. And now the sun in our code, all we really care about is the direction of it. So we're going to need to create a new uniform and pass it into our shader. So we get to go back into the familiar world of JavaScript for a moment and jump back into earth.js. Sigh of relief. Now, up in our uniforms, in that object, I'd like you to create a new uniform, and we're going to call it sun direction. And that is going to be an object, and we set the value of this uniform. So we write value. And we're going to set that to a new vector 3. So this is a 3 vector 3.
How do I? Oh, 3.vector3. Do we import
no,
3?
we don't. We imported 3, so we're not going to write 3 vector 3 because this is we're doing the modular version of 3 here, which is cool because it means at the end we can tree shake it. Nice. We can get rid of all the things in 3 that we don't actually use.
Cool.
So yeah, you'll need to import a new vector 3 from 3.
Cool.
And then down here we'll create one. And so just for now, so we want to get like a nice, just so when we're debugging, we'll get like a nice 50-50 split between the night side and the day side. And so to do that, let's put our sun all the way at the right. And so that would be, the X value would be at 1, right?
Okay.
The center of the screen is 0. The left-hand side is off to -1, and the right-hand side of the screen is 1.
Okay.
So we're gonna put the sun over just on the right
over
and
here.
On the Y, and there's exactly.
This is 0 and this is -1. Got it.
Exactly. And so on the Y and the Z, we're just gonna set those to 0 because we want it to be 0 on both of those. So now we passed in this new uniform. Let's go use it. So hit save there, and let's jump back into our Earth fragment.
Cool. So can I? So I can. All right. If I'm passing it from JavaScript to like in through uniforms, do I have to first grab it from my vertex shader and then pass it down, or this has access to it? Okay, cool.
So fragment shaders and vertex shaders both have access to the uniforms passed in via JavaScript. The varying stuff can only go from vertex to fragment.
Cool.
They're like a special type of kind of internal uniform that can only be passed between.
It. So it's not like with React, if you're familiar, where like I would have to pass the props down both times, and if I didn't pass like from the parent component to the child, it wouldn't be there. It's more like context or something where like everything down the pipe has access to it and can take it. Cool.
Yeah. So uniforms are variable. So I've been saying varying uniforms, which is actually incorrect. They're both variables, right? So you have uniform variables which get passed down from the JavaScript or somewhere else into the program, the WebGL program.
Cool.
The varyings are passed from vertex to fragment.
Okay, cool.
Different kind of variable. Varyings are not uniforms, even though I've said varying uniforms.
No worries.
they're not actually uniforms.
Cool.
They're variables.
So am I doing a uniform here?
Yep, that's correct. So we're going to put a uniform there, and we're going to pull in our sun direction.
Cool.
Nice. Now, in the same way we're reading the day sample, we're going to read our night sample at the top. So we're gonna read our our texture. Yep. So we can just change day to night, and we'll be pulling that in.
Oops. Cool.
Nice. So now we want to basically just get the angle of the sun, and work out the angle from the sun to the normal that we're on. So kind of like we've done below with dot, we're going to use dot again. And so we're going to create a new float, which we can call angle to sun, or angled to sun, angled sun to normal, whatever you want. Yeah. Yeah, angle to sun, that works fine. And so we're going to use dot again here. So we'll start the dot method, and we'll pass in the v normal as the first parameter again. And then the second parameter will just be the sun direction.
U sun direction, right?
Yes, U sun direction, cool. Exactly. And then we're going to create a new float, and we're going to call this mix amount. So what we've done here is we've got the angle between the v normal and the sun direction, and then we're going to work out. So that's going to be a value from -1 to 1, and because we're going to be mixing. We're going to now use that value to mix between our day and night textures. We want to just shift that up so that we don't have 0, 1, -1 to 1. We have 0 to 1. And the way you can do that really easily when we know everything is normalized is we can get that angle to sun, and we can times it by 0.5. So let's imagine we were at -1. If we times that by 0.5, we then have -0.5. And to get from -0.5 to 0, we plus 0.5. And that is going to map and then plus 0.5. And just doing that, timesing it by 0.5 and then plussing 0.5 will map a range of -1 to 1 to 0 to 1. And it's a good way to, yeah, it seems really simple, right? But if you play with that maths like in the console and you change what the angle to sun is, and you go from -1, like -0.5 to 0, you'll see that it's perfectly scaling.
Makes sense, yeah. No, it checks out.
Yeah, maths is weird like that. Like you do something like that, which just seems quite counterintuitive, but when you break it down, it's doing it.
That's really handy. Awesome.
Yeah, because we don't want minus values here. We want a value from 0 to 1 to mix.
Because we're going to colors, and colors need to be between 0 and 1, correct?
Like exactly. Exactly.
Awesome.
You've got it, cool. Man. And so now in our final color, which we're doing the day sample and the plus the atmosphere, I think what would make this a bit cleaner is if we get below our day sample at the top, where we've got day sample, night sample,
right?
Let's just do that, adding the atmosphere up there, just because it takes it out of our final color stuff. So on line 10,
okay.
Yeah, exactly. So there on line 10, we can do this, but we actually, paste that in. Rather than create a new variable, just paste that line up there. And what we can do in GLSL, in WebGL world, is we can just change that plus to a plus equals.
Cool.
And then that's doing the exact same thing. It's just adding the atmosphere to the day sample without having to create a new value and
just for the sake of,
and call it like, day sample plus atmosphere. We can just do that.
Okay.
And now we've got that. So now day sample has baked into it the atmosphere.
Nice.
And so now we can, in our final color, the reason we've done that is because we're gonna add a method to our final color, and this just keeps it a bit cleaner. So what we want to do is add this method called mix, which is so this is in final color on line 90.
Right. Okay, cool. Mix.
We're going to use mix, and mix does exactly what you think it does. It just linearly mixes and interpolates between two values.
Cool.
So we're going to pass in the night sample first, and then the day sample second,
and then the mix for how much we're mixing from one to the other, right?
Exactly. And that mix amount we've already created up above, which is our angle, right? And so that's just going to go between. So if you hit save and we
Awesome.
take a look back at the screen, we
Dun,
should
dun.
have
Where'd I put the one? I have a one. No, or just okay. It's not a float thing. Weird.
oh, we've got a proper
Something.
one we get to debug. Okay, brilliant.
Nice.
Let's open up and have a little look. Can you zoom in a bit
Yep.
on your, so we can all see? Nice. Unite texture is an undeclared identifier. Ah, so let's go down to 97 here.
Texture. Okay.
If we
We're
scroll
going
up,
where?
well, I think if we go back to DevTools. Oh yeah, it's up there. We haven't pulled that uniform in.
Right, like this? Like
Yeah,
that?
that's correct. That's
Cool.
all we needed to do. Yeah.
Cool. Still no. Atmosphere, undeclared identifier. We call this here.
Yeah, because we
We
create.
have to.
So
Yeah,
let's just move this down then. So let's just create a new line above the final color and move where we're adding our day. I would just move the day sample,
Okay.
that line, but down there. I just do it down there. Yeah, that's fine.
Amount, angle to sun. Okay, cool. All right,
That
nice.
all makes sense. Yeah. So we were using a value before we had
declared it.
declared that value.
Nice.
Okay.
Can we make this a little bit bigger so chat can see like more of the details, or should we wait on that?
Yeah.
I've been trying to do
the
plus minus thing, but it doesn't work for that stuff.
Yeah. So to do that, we can just go to Earth.js.
Cool. And then
and we're just going to up. Yeah. So we can just change that to 200, maybe 300. Chat will let us know if it's still not right size.
That's pretty good. Maybe
that is pretty good.
20 just for now, and then later when we have markers and stuff, we can go. I just want chat to be able to appreciate that. Like, look, it's going from day over here where there's not like a lot of lights or anything, and then as it goes off to the left, we're getting darker, and we have this night texture fading in as it moves over. Chat, how cool is this?
So if you want to play around with the mix value, we can hard set that to 0. And then we'll just see the night texture, all of it,
cool.
Which is quite nice.
So mix amount,
just
0.0, right?
Yeah. So we should just see.
That's what it would look like if it's completely night. So you can see it's definitely mixing. It's not just like a hard split. Yeah, you got a little bit of that overlapping. That's really cool.
Real nice. So I like it, but I feel like we bring it in a little bit because we're going like a straight gradient from like it's only pitch night at the left hand side, and it's only perfectly day right at the right hand side, and I want to bring those values in a little bit. So what we want to do is to sharpen that edge between the two. We're going to update below our angle to sun before we create our mix amount. So line 12. Let's create a new line under that. And so what we want to do is do angle to sun equals, and then we're going to use the clamp method. So if you think about it, we've got this scale -1 to 1. And what we want to do is we want to kind of like make that line harsher in the middle. And the way we can do that is we can just scale up that range. So if you go angle to sun and you say times it by 10, we're now going from -10 to 1. So sorry, -10 to 10. So let's do that. Let's put angle to sun and we'll times it by 10 in clamp. So we're kind of like increasing the range.
In clamp, cool.
Yeah, so it will be clamp, and then first parameter will be the angle to sun times 10. And then we're going to clamp it from -1 to 1. And so this is another one of those kind of terse, kind of condensed bit of maths that we'll break down. So we've got this scale -1 to 1. We scale it up, and then we clamp it back down to -1 to 1. And what that will do is mean that if we look at our screen, we'll then have shifted everything so that we now have a harsher line down the middle.
Much more clear. And this is more realistic to what like how the sun or
I mean maybe, I don't know. I've never been in a spaceship, but
no, me neither, and definitely not in the Tesla that floats around the Earth, as someone in chat mentioned.
That definitely not, not yet. Cool. So we've got day and night happening, which is pretty cool.
like with shaders. Like that's really really freaking cool that we're taking JPEGs, we're blending them, adding this atmosphere and the light effects. Like this is wild that we're able to do this all
Yeah.
with shaders.
And we can animate it, which I think our next step should be. Let's get
I
this
agree.
moving.
I agree. Let's do it.
Okay. So to do that, we're back in JS world, and we're gonna manipulate that sun direction vector.
Got it.
Um,
Cool.
so if we have a little look at Earth, we haven't got much else in here. So we're just gonna basically create a little within this component. We're gonna now create our own RAF loop. We're going to create our own animation loop. So underneath super, again, this is why
in the constructor or outside of it.
In the constructor underneath super,
cool.
we're just going to add some events. Now this is one of the cool things about our setup is that we can just do this very easily. So we just want to write e dot, and I guess we should import these. So if you delete that dot, hopefully it will give you some options. So we want to do that first one there. Yeah, let's import that. And then we want to do dot, and we want to write global events.
Should I do this? Probably, right?
So yes, cool. That is what you want. And while you're up there, in that object, let's add global events because that's also in utils. So we'll pull in e and global events.
Cool.
In your own boilerplates, this might work differently, but all we're going to do is we're adding our animation callback. So we'll do e.on, and then global events, and the name of this global event is RAF in all capitals, so .raf.
Cool.
And then we're going to, as the second param, we're going to write this .onRaf. We're going to call a method called onRaf. Which we don't have yet. Yeah, exactly like that. You can do it lowercase or capitals. Now we don't need to call it like that there, because what we're doing is we're passing this callback, and it's going to use it. So actually, rather than create onRaf above, we'll create that underneath the constructor as a new method on this class. So if you just write onRaf, not as a function because we're in class world, and actually. To make it even more fancy, there's a thing called class properties. I think it's called class properties, which is an ES6 thing. And rather than have to bind this RAF method, the scope of it, to this instance of the Earth class, what we can do is we can make onRaf a property, which means that it already has all of its instance variables because it's a property of this instance. So what you could do this, and we could run it. In fact, let's write it like this. We'll run it. We'll see it break, and then we'll change it to a class property.
We're a little short on time, so I think
let's not do that then.
Yeah,
okay.
Just because I don't think that this is as good of the class property thing versus something else that we can touch on. I think is more of the meat.
Fair.
If that makes sense.
Totally got you. Yeah. So if we write equals after onRaf before, so we're going to create an anonymous function basically. So onRaf equals create an anonymous function, which is just that. Yeah. We want arrows after the after the
arrow function. Cool.
Yeah. And then now we've got a anonymous function called onRaf as a property. Within here, we're just going to say, what are we going to say? Let me pull up my notes. So we're going to so we're going to update the uniform. So we're going to write this .material.uniforms .usundirect.
This material.uniforms.
So so because the uniforms we just declare up there, I think we probably could just write this .uniforms. Actually.
So I think it was yelling at me that that didn't exist. Cool.
Yeah, the material does exist though because this is an extension of mesh. It does. We can write this .material.
Okay, cool.
But we'll do this .uniforms just so it's clearer, and then we'll do usundirection, which is the uniform we want to update. .value.x, and we're going to use math math.cos.
So equals math.cos, right?
Yes, sorry, equals math.cos. We're gonna pass in a time value, which is actually gets passed to this onRef callback. So we'll put that in there. Yep.
So just time, is that the only thing it gets, or?
That's that. That's it for now. Yeah.
Okay, cool.
And then we'll do time, and we want to slow it down. So let's just do time times 0.1.
Cool.
And then we can copy that line. That we won't need anything else after that.
Okay, cool.
We can copy that. We can copy that line. And then we're going to do the same thing with sign on the z-axis. And what this is nice, because normally, you know, we'd have to pass in like distances and things like that. But because we're working with a normalized vector, we don't need to do that. We don't need to, because we're only working with 1, 0. We don't need to like push it around the radius of our sun, or because there's no physical object in physical space, right? It's just the direction vector. So we don't have to worry. We don't have to worry about making sure that this is actually orbiting around the radius of our sun. We just need to update these values. So if you hit save here, we should see what's going on in the console.
Check. Oh, we're getting lots of errors. Kind of read properties
Okay.
undefined. Reading use
Okay.
Direction.
So we do need
material.
we do need to do this material. Yeah.
Cool.
A material is a property of the mesh.
Cool.
This class that this extends.
Got it.
So that's why we don't see it defined.
Ooh, chat. Look at this.
It's pretty nice, huh?
That's
and so it will.
So cool. We'll see night come in soon.
Let's wait for a second. It will. Yeah. It will take a second. It's orbiting. Now the sun's in front of us. It's orbiting around. It will take. I mean, we could up the speed of this, but here you see it creep in. This is a nice kind of dramatic effect.
Look at this.
Pretty nice. Look at that.
Really cool. Hitting at 60 FPS. Love it.
And that's what's nice about doing this in one mesh. You could try and do this with 2 different meshes, one for day, one for night, but doing it all in one shader means it's pretty performant.
And I do want to say, like, it gets things right that I feel like if I were faking it with like a div and some other stuff, I wouldn't get right, where it takes a lot longer when the line's coming in front of us. Like right now, it feels like it's going slower than it does at the end, right? Like, and now it seems to go a bit faster, but that's just how it looks. So cool looking.
Just the perspective. Yeah, pretty so sweet, cool. Right?
Yeah.
So how are we doing for time? Because
we are a bit over. Do we want to kind of jump ahead to either to the end or a couple commits and kind of see what we've got and then talk about how those things are done?
Yeah, that sounds like a great idea.
Awesome.
So you're in Git, aren't you? And you're at a detached head. So I think we're going to need to stash everything that we've got.
Okay.
So I think you can just write Git Stash.
Yep. Stashed.
And then we want to check out the latest commit. I think you can do Git checkout head. Okay, now let's refresh and see where we're at.
I think I'm still.
Oh yeah, No, that should be fine. You got to run npm start again.
Okay.
But I think you should be.
Head detached, nothing to commit, working tree clean. I don't know. It seems like I'm still on that commit.
You're still on that hash, aren't you? Okay, so git checkout master, or is it main that I'm on? Did I write main? Yes, it's main. So git checkout main. Yeah. There we go. So now we're right at the end of the project. So we've got a few extra bits in here.
npm start.
Yeah, npm run start.
Do I need to install anything, or is everything already installed?
You'll have it already installed. Yeah.
Awesome.
I think so. I think because you set up the project at the end, so you ran npm I at this point anyway. So we give it a refresh.
Whoa.
Yeah. There's some more stuff happening. So I haven't linked these things up to buttons, but if you open up your console and you type in what have I called these methods? I've called them like, I think if you write like window.animate to animate to location, that's the one. The locations we've got London, we've got Connecticut where you are, and we've got Sydney. So pass in a string of Connecticut. See if I've spelt it right.
See if I can spell it.
Yeah, I don't think cannot
let's
read
try-
property of undefined. Yeah, I think it might. It's all lowercase. I don't think I've
cool.
put
That makes sense.
Yeah, yeah. So that
Whoa, nice.
so
Super quick,
now
can we do that thing again, or is that gonna mess it up? Just so chat can see a little bit better. Is that gonna screw up the positioning
can
of
we
things?
do can we do what again?
Sorry, make the Earth bigger, or is that
Oh
gonna screw
yes,
stuff up?
we can, and we can do it in CSS now.
Ooh, really?
Yeah, yeah, we can. So there's some of the stuff that you've just brought in includes some stuff that will sync the Earth size and position to a div. So if
Wow,
you open
that's
up your,
clever.
it's pretty cool. There are some caveats with it, but generally it's a really nice technique. So if you go into
Nice.
resources, and then open up assets, and then open up SCSS,
Okay.
components, a lot of boilerplate, and go to earth.scss, that last one.
Cool.
Then
What does that stand for? Because I should.
that stands for Ash's smooth scroll.
Cool.
It's a pretty
Just
popular
wanted to
npm
clear that
package.
up for the chat.
Yeah. If you guys are looking for smooth scroll libraries, ASS or AS scroll, I didn't name this, is probably the best smooth scroll library out there.
Cool.
It's built and maintained by Ash Thornton, who is a developer at GC. He's the lead creative dev. Very, very lovely, smart guy. And yeah, so we use this smooth scroll library on
Awesome.
all of our projects, and it's brilliant.
Nice.
So here we go.
Okay.
Here's Earth. So we can
Yeah, so we
just
can
change the
go
size. So you
like
can see here, you can do it. You can center it in the screen if you want.
you can even do like pixel or percentages or something, right? Like
Yeah, you could do
25%.
it. Yeah, because with
Wait,
20.
hold on. I should be doing bottom and left. I should be doing okay, so you've got that. Yeah, it did feel like a percentage based thing.
Yeah,
So you got the view width.
yeah,
Let's hit
and so you can do
refresh.
20, and now we'll be
Nice.
up there.
And then so
Real.
we
If
did
you want to
that.
center that, you.
That's so
Yeah.
cool. And then nice. And the last one was what? Sydney?
Sydney's in there. There's also a place in here called Null Island, which Null Island is a boy that lives at the latitude and longitude of 00, and it's in the middle of the sea. I think it's Null Island without. Let me double check what I've called that.
It's camel case.
It's camel case. Yeah, and that's
Nice.
that initial dot. And you kind of need that to center everything so that you have that, like,
Oh.
because you're always moving from angle to angle. So it's important to know where our center point is so that we can
Got it.
work with that. That's kind of our like base value.
This is so cool. Like the locations, the quick moving of the. So are we moving? We're moving the globe. We're not moving our camera
Yes.
here because I can tell
Yeah,
because the sun's going to the left and I'm going to move it and the sun's still where it was. It didn't shift. Like the Earth is moving really quick, but the sun and the camera are staying fixed. Well, there actually is no sun,
correct.
which is a pretty cool trick that I assumed when you showed this to me that we were having a light orbit around and you were doing something with that. But there's no lights in this scene, right? Is that?
No, there's no lights in this scene, and that's part of why it's nice and performant. Is there's no kind of real-time
Yeah,
light calculation. We're just mixing between two images that are wrapped around the sphere in a smart way.
that's
Um,
really freaking cool.
yeah, all on one mesh, which is quite nice.
Yeah.
Um,
And then so you could
so
have it so that when I click on these dots, that it moves it the same way. So like on click, animate to location, right? Like that's
yeah,
essentially why that function's there.
yeah, exactly. So you can go through all your markers and you can make them clickable using the intersection observer in Three.js. I don't know if that's something that's been covered on front end horse.
Not too much, but I think once or twice. But it basically uses ray
casting. Yeah, so
casting.
it
Thank you.
shoots
There's ray tracing. There's
shoots
ray
out.
marching. There's ray casting. It's everything with
Yeah,
rays.
yeah. And that's really useful doing that. And so then, yeah, you could make these clickable and you can click
Cool.
around between them. So I don't know how much time we've got to talk about this because there's a lot in here now. Is there anything in particular that you want to like go over? Because I guess there are two things really. There's like, we can whiz through how the markers work, or we can whiz through how the like WebGL to DOM mapping works. I think
Oh
there's probably
man,
enough time to do either of
both
those.
really good things. Yeah. So we've got a couple of questions from chat. Would you be able to
Yeah,
take those questions in the
yeah,
Discord,
sure.
like afterwards? Would that be
Yeah,
cool?
yeah. I'm gonna hang
Chat, is
around in the
that cool?
Discord
Because
for a bit.
I know Adrian and Life are both in the Discord, so that's kind of why I'm saying that. So if that's cool, I think there's some good questions. I know Life has asked a couple, and we got a couple over here on our little thing that catches questions. So we'll make sure that these get answered in the Discords. Sorry,
Yeah,
I do have to hop after this. Otherwise, it'd be like, all right, we can just hang all day, like
yeah.
so. So I don't know.
Look,
I'm trying to think of which to go through there. Actually, I think Adrian's question of how do the markers work? Are these Three.js elements or are they DOM
they
elements?
are. Those are
Okay.
spheres. Those are spheres that live
Okay.
on the globe. And what we do is there's some maths that we use to convert the latitude and longitude values. So you can just find any place on Earth. You can Google Connecticut latitude and longitude.
Got it.
Google will give you those values,
Right.
and then I just create an array of these values and the locations. And then we loop through those. And there's some maths that will then place those on a sphere, and that's how we add markers to. So we're drawing spheres at latitude and longitude coordinates that we pass in. So you can draw spheres wherever you want in the middle of the
But
ocean.
then you have to like map them to a sphere. So you've got some like pi kind of math involved
Yeah,
there, and in order to go from the center of the sphere, go out to the radius of the sphere, and then like put it in the right spot essentially, right?
yeah.
Where can I go just to kind of glance that code in case
So
someone's
if you
watching after
go
the
to,
fact?
I think it's in earth.js.
Oh, cool.
If you go to there, you can see if you scroll down. So there's our locations, our latitude and
Right.
longitudes. That they're up there just as a const.
Right.
If we go down further, we're creating here we go, add location markers.
Cool.
So
Lat long
we
to
create,
vec3. Got it.
yeah, so lat long to vec3 is a math, that's some maths in here. So you scroll down further, you will find lat long to
There it
vec3
is.
thing. And
Math
it's
utils,
all we're
degree for
doing.
radian.
Yeah, so we're getting the latitude and longitude we're converting those degrees to radians, and then we have to take away 90 degrees from our latitude and longitude. That's just because of how Three.js creates objects and how the latitude and longitude, everything's like off by 90 degrees, so you just have to like move it around.
Okay.
And then you just pass in the radius, and that's it, and it will give you a vector 3 on a sphere with that set from spherical chords. So you just pass in radians, which are the
Very
angles.
cool.
It's really easy because latitude and longitude are just degrees, right? It's just like from the center, one on the latitude is 1 degree, like
Okay, cool.
left or right.
Got
So
it.
they're just so latitude and longitudes are just degrees. And so we convert those to
Cool.
radians, which is what the spherical maths in 3 wants. And that's how we place them. So that's how we get the
Awesome.
location, and then it's as simple as just drawing an object where
And
that
then
position
we
is.
can do the ray casting bit and listen to see if this is in the list of targets, right? Or if it's the first target. I forget exactly
Yeah.
how to do it. Cool.
Yes, that's how you do it. Yep. Yeah. And you can make them clickable with that.
Awesome. And then you can pop up either DOM nodes or make something happen in Three.js, right? Like it's JavaScript at that point. You can trigger whatever you want, right?
Exactly. Yeah,
Awesome.
that is exactly it.
Awesome. Cool. So we touched on the markers. Do you wanna? I got maybe like 5 or 6 minutes most. What was the other bit? I'm sorry.
So the other bit is how we map this to the div, which we
Oh
can
yeah,
go
yeah.
through.
So how we did
So
like how this is changing the size of this.
yeah, like how do we do that, right? Because we were
Yeah.
going from like CSS, HTML DOM world into
Right.
WebGL. So the way we do that is if we go into the WebGL JS file, scroll up.
WebGL.js. Okay.
There you go. So what we do, if we go down to where we create our camera here, there's some maths that I do not understand, but
Okay.
well, I don't really understand it. But what it does, I can tell you what it does.
Where's the
So
camera
if you
bit? Here we go. Right here.
here we are. So what we do is we store the camera position, which we've set really far back. And the reason we've done that is because we're using a perspective camera. The further back we are, the less distortion we get, right?
Got
And so
it.
that's
Yeah.
how, even though that sphere's in the bottom left-hand side, it's not super distorted, which if we
Right.
change that value to like 200 or 100, we'd have like an oblong as it distorts with the perspective camera. So we just move the
It
camera really
becomes a
far back.
fisheye lens kind of look at the world where, right?
Exactly,
Yeah.
exactly. So we either need to make our thing smaller or we need to do this, which is bring the camera position backwards.
Cool.
So then the bit that's like really intense and I don't understand is this field of view calculation. So it gets 180 times is that by the ATAN of the height of browser by 2, and then divides that by the camera position, which is the Z position,
Okay.
divides that by pi, and what you end up with is a system where at 0, 0, one WebGL unit is equivalent to 1 pixel. And so now we have a relationship between the WebGL units and pixel units. And that means that we can then go into Earth.js.
Because of
I
that,
don't,
because
this is,
we're
yeah,
grabbing the height
yeah, we
here and we're
yeah,
building that into the field of view.
yeah, it's
Interesting.
the field of view then has a relationship to the size of the DOM and the amount of pixels in it.
Ah.
Um, And so if you go to, and again, this is maths that I like barely
No
understand.
worries.
It was
Yeah.
something that someone gave it to me and they said the exact same thing. They were like, I don't know how this works,
We're
but
all
this is what it
standing on
does.
the shoulder of Mr. Tube and someone else, right? Like that's
Exactly.
don't worry about it.
Yeah. And so there are other techniques to achieve this that don't involve changing the camera field of view,
Okay.
which is useful if you're working in a scene with other elements, because as soon as you change the field of view here, if you want to do more complicated things, that can mess you up. And then
Got it.
but most of the
That's
time
really
this is
neat.
fine. And if you're doing, especially if you're doing things like just trying to replace an image like a plane with an, so if you've just got images that you then want to render in WebGL and map to your DOM, this is a great way to do that. Is you can get this set up in, and then you can then get your images that are normally just HTML images, and then you can render them really
Cool.
easily.
Sorry, super quick. How does Earth, how does the
What
Earth
does Earth
class
do?
factor in? Yeah, I'm not
Yeah,
seeing
yeah,
that.
yeah.
Am I
So
missing it?
there is a missing piece that we haven't covered. So if you go
Right.
to earth.js, there will be
Earth.js. Cool.
a sync DOM size thing.
Ah.
So what we do here is we get the bounding client rectangle of the DOM element that we want. And then we create these two values called the width pixel and the height pixel, which is basically the reason we're dividing by 2 here is because we're using a sphere that is sized by radius.
Got it.
So we need to divide by 2. And we set the scale of our object to the width and the height pixel values of our, because we start, if you scroll up here, our sun's radius, where we did have like 200 or whatever, so the chat could see it. If you scroll
Right.
up, the radius that we create should be,
Here. Right.
yeah. So the radius
Radius. We're getting
is
that.
being set up at the top.
Okay.
There you go. So the radius here is 1, right?
Okay.
And so when we scale up by say 20 pixels, we then create a object that is 20 units size, and we know we can. And because of the camera picked up, we know that then it will fill the space on the screen that is equivalent to 20 pixels.
Got it. Awesome. That's a
Yeah, and
really
so
neat
that
trick. I haven't heard of that before, so that's it's nice being able to go in and change the size of that with CSS, because then I can, like, I mean, for me, if we work together on a thing and you handed it off and I've got to go do responsive views or whatever, I can maneuver the earth and resize it based off of just a few key properties that I know like the back of my hand. That's a
yeah.
really cool trick. So thank
Yeah,
you
and
for sharing that.
no worries. No, that's great. It's no worries. It's a great trick. And nowadays, mixing WebGL and just regular old DOM is happening a lot on the web. And so having good techniques on how to do that like become important,
Yeah.
So yeah, it's great. I love this trick. And we'll get this boilerplate into a public GitHub repository, and people can break it
That's
all down and
awesome.
have fun with it.
Luke, thank you so much. This was such a cool episode. We got into some really neat shader stuff. I still just want to watch this effect. I kind of want to, like, I don't know, I just want to have it like on in the background. It's just, there's something really like calming or soothing about it. Just it like to
Yeah,
zoom out on the world and just kind of see it from out there. It's just nice. It's really, really
yeah.
cool.
And there's so much more people can do with this. You can add a specular map that represents water, so that kind of
Yeah.
reflects more. You can add an outer glow to things. I've worked on a
Yeah.
project where we add like region highlighting, so you could like highlight regions.
That's
Um,
cool. Yeah, it
yeah,
seems like the
that
sky's the limit once you kind of understand those basic principles of, like, you
yeah,
can add and subtract JPEGs and whatever else the heck
yeah,
you want. It feels like, oh yeah, I can kind of figure out what you just said. For the region highlighting, I would get like a texture that just has, say Africa highlighted on that texture, and that becomes another thing that I add or subtract, or that's just added at the end and that's always there because I don't want the dark to hit it, right? Like, I
yeah,
can figure it out now that you've kind of showed us how to add, subtract, and manipulate these things, and the normal tutorial was great. Man, thank you so much. Chat, some more confetti. Let's give Luke a nice. We don't do round of applause. We do more just like showering you and all the emojis that we can think of. But man,
nice.
thank you so much. This was a fantastic stream. We made such a cool Amit Sheen, who is famous for doing 3D CSS stuff, comes in at the end and says, I still think you can do it in CSS. Like, I don't doubt you, Amit. I would never challenge you to do something in CSS because you probably can. I can't wait to see it tomorrow. But yeah, Luke, man, this was fantastic. And not to pressure you, but if you do have any time in the Discord, I know Life has a couple of good questions and would love to pick your brain about it. But to anyone else who is out there, we have a fantastic show tomorrow. We have my friend Mambaleo, also known as Louis Hobrix. Hope I'm saying that right. I haven't said that in a while. Coming on to teach us how to make a Figma plugin. It's super cool. He made this awesome Figma plugin that generates SVG. I love Figma. I can't wait to learn about how to make a plugin because it feels like it's one of the best apps, and then to add like my own things on top of that just seems really freaking cool. So he's coming on. I think it's his second or third time coming back to the show. So really excited for that show. But yeah, if you're not following already, go ahead and follow. And Luke, real quick, what is your site again, Luke?
LukeBailey.io.
Cool.
I'm Luke Rohan Bailey on Twitter as
Cool.
well.
And does your personal site have your Twitter? I'm just making sure. No, I don't
No,
think it does. So let
no,
me.
it doesn't. It doesn't. It's thank you. Luke
No
Rohan
worries.
Bailey on
I just
Twitter
want
is
to make
me.
sure that people can get to you and follow along. Man, thank you again. Yeah, chat, thank you, and we'll see you tomorrow. Let's find someone to raid. And yeah, take care. Bye, everybody.
Cheers. Thank you. See ya.